It's time for us to start talking performance. Right now we have 2 players in our game that can shoot an unlimited number of bullets that just keep flying around forever. So we can see that bullets are flying. I can look over to my left side in my hierarchy and see new shots going off constantly. And when shots land and hit things, I can see that I get a shot that appears and disables itself over time. Now, right now, this isn't going to cause any problems. I can run around, shoot many hundreds of times, and my game's probably going to run fine. But eventually, it's going to slow down. Depending on the system, the problems are going to come faster and faster. If you're on a mobile device, they're going to come much, much quicker than if you're on an extremely high-end development system. But let's make it a little bit easier to reproduce the upcoming problems that we're just about to solve and to view them in the profiler. We're going to stop playing, and what I want to do is open up our blaster script. We're going to go find the blaster on our player. And we're going to make a quick modification. Instead of firing when we pull the trigger down, we're going to fire every frame that we're holding the button down. We'll do that by going into our update method, and I'm just going to copy line 17 up to the dot part. Everything up to the end of the fire and the braces, and paste it in here. I'll put that inside an if with some parentheses, and I'll say if that dot get, or no, it's a read, sorry, I lied, read value, and it's of type float, not get. It's a read value. We're going to read a floating point value that's going to be 0 to 1. If it's greater than 0, then we're going to try firing, or just do a fire. So we'll just try fire, and we don't have an object or a context, a callback context to pass in, so we're just going to pass in null. Actually, we can't even pass in null. We're going to have to pass in a new callback context. So instead of doing that, we'll just take this line here, 22 and 23, and we'll add some braces and paste it in. A lot better than calling it and creating a new context. We don't want to start causing other issues. So there we go. We've got our launch code inside of the update, and I'm going to comment out line 17 so that we don't ever call try fire. We just call it in update right now, and we're again going to call this every single frame where we're holding the button down, so we can spam out shots and then take a look at the performance characteristics of that and see how we can optimize it. So let's jump back into Unity. Now we're in play mode, and let's hold the button down and look at those shots start firing. I'm going to get my other player in, hold this trigger down, and look at all those shots go blasting off. Lots and lots of firing. So what's the issue? Well, if I hold it down for long enough, eventually I'm going to start to see my frame rate dip. But like I said, that's going to probably take quite a while on this system. It's got a lot of memory and a very, very, very beefy CPU and video card. So it might be pretty difficult for me to see the slowdown just shooting these. But I can see that the frame rate is starting to drop. It's going down into the 20s and 30s. It was in the 50s and 60s a moment ago. Let's take a look at the profiler, though, to see this data, I think, even quicker and a little bit more visual representation of what's going on. If we go to window and we go to analysis, right below sequencing, and go to profiler, this will pop up the full-on profiler window. This may or may not be docked. I'm going to grab it and just dock it down below right next to our console. I'm going to drag it up just a little bit once I've got it selected, and make it just a little bit bigger. Now, if you scroll down here, you see that there are actually quite a few different profilers. It starts with the CPU one that shows just what our CPU usage is and shows us each thing that we're running each frame. So it'll tell us what thing took the most amount of time. If I go through and sort by time, I can find each frame and see that, well, here we're actually getting a little bit of work in the physics 2D fixed update. That's actually taking 9 milliseconds. And if I scroll through, you can see that the time on that looks like it might be going up, but it's a little bit hard to, there's one where it's at 18 milliseconds, which is really, really high for a single call in there. But let's scroll down and see the part that I think is more interesting and even more apparent. If we go to memory, and then we choose this option to see the current frame, and then unpause, we can actually see the memory allocations live. Well, let's go back to that profiler tab, drag it. If I could click and drag, this would be a lot easier. We can actually see the allocations happening. If we look down here at the other, we can see how much memory we're using with our own objects. And if I just start holding the buttons down watch as those memory allocations just go up, 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 and up. We're going to keep eating up more and more RAM, and eventually our game is going to blow up, or we'll run out of system memory or something else, or the whole thing again is going to slow down. Oh, look at that. We can see our performance is actually dropping quite a bit now, even on this high-end system. So we need to do something about that. We've got to fix the problem. Now, one solution is just to destroy all of those objects that were appearing and have them get kind of cleaned up instead of disabling them. So let's go through that next. Let's open up the blaster shot script. If I can find my blaster shot, there we go. And instead of disabling our game object here on line 40, let's destroy it. We'll say destroy, and we'll pass in our own game object. Now we'll add a semicolon at the end, and this will immediately destroy our object. So we shouldn't end up with all of that physics work that's going on. We're just going to have all of our objects being created, landing, hitting, and then getting destroyed. It also should reduce the amount of memory that we're using, because we're not going to keep those objects around. We're going to create them and then destroy them. That does, however, cause one other issue, which is going to be memory fragmentation. Let's check this out, though. We'll press play. And in just a second, we should be able to get our player in here, start shooting, and look at the memory usage. You can see that it's going, about the same. It's going up a little bit. It's going to drop a little bit. Let's shoot some more. And look at the memory usage, staying right around, what is it, about 410, 412. It's no longer doing that skyrocketing and kind of going up, up, up and away, which is what it was doing before. Also, our performance isn't dropping nearly as fast. Let's face the other direction, though, just so we can get more shots going and staying around for a little bit longer. But and that's another thing to note, once we shoot off to the left, our shots aren't getting destroyed. So we need them to actually self-destruct as well. So we'll stop playing, and we'll add in one more bit of code in here to our blaster shots to make them self-destroy after some certain amount of time. So we'll go up into our awake method, and right after we launch ourselves, or right after we get created, let's just say destroy, and we'll destroy our game object, and then we'll give it a delay of some maximum lifetime. I'm going to make that a variable and call it _max lifetime, and then we'll generate a field for it. Alt-enter and go down and generate a field. F12, we'll go back, replace the private with serialized field. And then I'm going to cut this line with Shift-Delete and move it up and paste. So we've got a max lifetime that needs a default value. I'm going to give it a value of 4 seconds, so that after 4 seconds, our object will automatically destroy even if it hasn't hit anything. Let's go check that out. And now we should be able to see that our memory usage won't go up even if we're shooting off to the left, where our shots just go off forever and ever and ever. Let's see. So press play. We'll face to the left, keep shooting, and our hierarchy should also stay about the same size instead of growing indefinitely. So let's check it out. We aim to the left and shoot, and I'll come in on another player, aim to the left and shoot as well. And we can see that the hierarchy, it's growing a little bit, but eventually it's going to stop. And see that the size of it isn't changing anymore. And you can tell just by looking at this that the size isn't changing. Now it's shrinking and growing again up until I get however many shots it is that I can fire over 4 seconds out. And once those disappear, as we can see, they'll start kind of cleaning up out of the hierarchy and disappearing, and then eventually they're all gone. If I go to the scene view and go to 2D mode, let's see, we can actually zoom out and watch the shots disappearing. Let's do it from just the other player. So we'll watch the shots from this player going out, and you'll see that over time, once they live for 4 seconds, they end up disappearing. And that's why our hierarchy ends right about here, and our memory usage is kind of peaked or capped right there. So this is working. This helps a little bit, but again, it does cause one other problem, which is our garbage collector is going to be working overtime because we're constantly creating and destroying objects. Now on Windows, on a super high-end system, doesn't make any difference. You're not even going to be able to tell on here. As soon as I go to a mobile device, though, you're going to notice a huge spike. So we'll talk about that in a moment. For now, though, we're going to go into Plastic and commit our initial changes that the blaster shots self-destruct and clean up. And we'll check that in.